Right, welcome everybody. How's it going? So today we're starting on something different. Last stream we kind of put an end to the encoder system, so I'm finishing that off stream because it's just getting to the point where we're doing lots of work which is in the weeds and very specific details. So it's not really the best type of content to stream. So we're going to be moving on and doing stuff in parallel. Basically, off stream, I'll work on the encoder system and finish it off because it's basically there. It's just the final 10%. And on stream, we're going to be doing lots of small tasks and just getting stuff ready to actually start working on the material editor, which is the first small editor to get done. And we can test all the systems and make sure they're all in a good place before we do the more complicated editors, see if there's anything that we're missing, and make those changes. So I'm hoping we can get this all done in a single stream, because the idea of wait a minute, is this coming through the right one? Good. Yeah, so we've done these two now, the entity system and the encoder system. So, ideally by the time we get to doing the material editor, this should be done off stream. We'll be able to save and load out text files and stuff, and binary files. The asset system, it's not going to be too complicated. We just literally want to load stuff from the asset folder. So we just want an API so we can sort of know, hey, this is where we're loading an asset, and we can change it later. So the way I think about doing it for now is just load it all into memory whenever you ask for the file, and then give you back a pointer, and just go from that system. Really, there are a few little things about it we will do though. And then, yeah, we'll probably move on to gizmos next, maybe renderer, mouse feedback, so you can get back an ellipsoid that you hover over. And maybe a UI color picker widget or something. Some stuff like that. Some small things over the next few weeks, or next couple of weeks, before we get to the material editor. Hopefully by November, we're starting on that material editor. That's the plan. Oh, let's get that over there somewhere. Right. I hope everyone's having a good start to your work week. So we need to make some new files. Source directory. This would be at the engine level, I reckon, because it's basically like. Yeah, I'll put it at the engine level. It's not really too game specific, right? Every game has assets. That's the sort of logic we'll go with. Call it asset. We'll do another one. Call it asset.c, and then an asset.h. And we'll just get going. That I did. Oh, wait a minute. I think I got some unchecked in changes. I forgot what I did here. It was some more CSON reader generation work. That was in the encoder system. I just did a bit of that off stream. That's a lot of changes. Git diff. Head up. Oh, it's actually it's not more, it was actually the CSON stuff. Okay. Anyways, tag that with the day before. Day 7.6. I've got the date on here, right? Yeah, 7.7. We're doing good. So let's tag that one. I'll push that up after the stream for those who are following the code. Right, so we just made some two files in the asset folder, asset.h, and it's in the engine directory for the game without an engine project. We're going to pragma once it, like every good C programmer. And yeah, so the way I thinking about this, right, is we want a way to load a. All right, let's think about this. Hey, iSense, doing good, man, doing good. Just been quite busy today at work, thinking about a whole bunch of things. So I've been quite in my head today, but yeah, it's been good. Lots of fun stuff happening. How about you? How's it going with you? So effectively, right, when we ship the game, there's going to be... Oh, okay, let's go the other way around. When we're developing the game, all the assets go in the asset folder. It's as simple as that. So the way we're going to refer to an asset is it's relative from the asset folder, and that's it. When we ship the game, these are all going to be packed probably into a single file, like a compressed zip file or something, or maybe they're done in compressed into multiple zip folders. You know, that's a more complicated system that we can build later on when we actually need it. But the same system will work, right? You give it a path relative from the asset folder, and you get back the whole asset in memory, and that's going to be the idea. But maybe the asset might not be loaded yet, and when you're in a game, you don't want to wait for the operating system to serve you up the file into memory. So what we might do is have a way to sort of signal and say, hey, bring that into memory for me. And then you can keep trying to get access to it. Yeah, and then you can keep it in memory until all the references have been removed or something like this. Yeah, something like that. So I think what we're going to need to do is probably have some kind of structure to say it's like an asset. Do I want to call it like a core, whatever? I don't think I want to do. Just call it an asset path. So there'd be like a capacity. 256 might be enough. We can always change it. Yeah, so maybe you can just say this one like... Good thing, same as you, fair play. Cool. Yeah, I don't know if we should make a distinct type for the asset path. That's the thing, right? Do I want to make like a distinct type for it? Maybe, right? Because if we just do a string, yeah, we might just do a char star. Distinct type probably ain't that bad, but you will have a capacity on it at least. But yeah, something like that. So we're definitely gonna. So I think what we're gonna end up doing is you need to make an asset ID, which will represent the asset that you have in memory. So I think we can use the core object ID thing that we have. Core define. Hey, I've got to include my engine core H. Yeah, so asset ID. So we're going to have a way to say asset ID asset open, and then you pass in a path, right? I guess you can const it. Then the other thing you want to do is be able to close an asset. So what this will do is this will probably be reference counted or something, but it'll tell it to basically load the asset into memory in the background, right? So find asset and load into memory. So I don't think, right, we're going to want to have big old assets which cannot fit into memory, or you maybe want to stream a part of it into memory. If we want to do that, we can always extend it. We're just going to load the whole thing into memory. Find asset and load into memory. If the file is already loaded, increment the reference count. Yeah, increment the reference count, something like this. And then this one is going to decrement it will only increment the reference count. Decrement and free memory if no more references to the asset. Okay, so with this, what we can do is we can now get a pointer back to the memory, I guess. Maybe it could be a Boolean. So you want to be able to say asset asset read, maybe. I don't think there will be any kind of like writing through this thing. Or asset memory, something like this. U8 star, maybe a void star. And then probably a size out, something like that. So basically returns true if loaded into memory. and sets pointer out and size out. Otherwise false. When the asset is not ready. So I think this could pretty much be the API. You might want to be able to get the path for a given asset ID. Um, yeah, I think this will do for now. We can always change it, right, where we might say, hey, open doesn't actually load it all into memory. Maybe you can load different portions into memory or something. But again, it just adds more complication, which I don't think I need yet. Um, um, so when it comes to like, we've got the editor, right? And say if I want to go, hey, I'm saving this file out, right? Or I do a file save as of, or something like this. I guess you'd save it out via just a file API, right? You'll just save it. And then you might load it back in through the asset system after you've saved it or something like this. No, you just update the path or something, yeah. You know, I might bring back the typedef asset path thing because I think it just makes a ton of sense. Yeah, I like that one a lot. So, right, I guess let's just get in there and start implementing it. Shouldn't take us too long here. So in asset.c, we simply include asset.h. Now I'm thinking about doing my sort of like, typically I have like an internal file so I can like include it outside of the compilation unit or like the module or whatever. But I'm thinking of not doing that soon because it's just adding more files and I like having less files. So we can have an internal section inside the C file this time and just probably go on with that with every file we make, and we'll see how it goes. And this is the public stuff. All right. Hey, Akraz, how have you been? Good to see you. It's been a while. Oh yeah, I've been affiliate for, I don't know, have I been affiliate for like a year or 2 years? I don't know anymore. Maybe longer. It takes me ages to get to the next level, you know, because you got to stream like this many hours and then you got to have this many people watching. We have like 70 people watching, and I think I'll just be staying like this for a good while. That's okay. I'm pretty happy with this many people watching. Otherwise, chat will be going crazy all the time, and we'll be able to actually have conversations with people who actually come here now. Hey, Pachi. Yeah, man, all doing good. Doing pretty good. I just decided to put a pin in the encoder system on stream and carrying on off stream. So we're going to be moving on to different tasks now, and hopefully just checking boxes, doing some small quick tasks. And then by November, we should begin to working on our first editor, which would be the material editor, where it brings all the systems together. And yeah, we can start actually making editors to help make content, which would be pretty cool. So we've got like a UI system, encoder system, graphics, asset system, so many things, and I cannot remember. And we bring them all together. Well, yeah, I guess that's it. Operating system abstraction, GPU and graphics layer. Bring them all together and building editors so we can actually make content that we can use. So this is the next sort of 7 months probably. Yeah. Yeah, it's just became a little bit too in the weeds, the encoder system. So it's not really good content, and it would just be good just to wrap that final 10% of the work off the stream, basically, and just do more, do some new stuff, new shiny things, Always like a bit of new and shiny. Keeps the motivation up, So also as well, this system will need to account for multiple threads later on, but right now we don't need to care about that. So the internal system is going to be called like asset system, I guess. And we fixed it with a global. G asset system. So as you can see, you have this asset path. With the asset path, we've got to look it up, see if it exists. If it already exists, return it with an incremented reference count. If not, just make a new one. And hey Pete, how are you doing? Good to see you. Yeah, makes sense. Great work. Yeah, thank you. Hey Voodoo. You see, we're going to summon different this time. Oh yeah. New and shiny. It's the best thing about doing a game project. You can always just switch to something else, and it's new and shiny. How's it going, Voodoo? What have you been up to? So good old ref count. Reference counter. Right. So we're gonna need to define some kind of hash table. Luckily we can do that with some macros. Right. What is the key? Asset path. Alright, that's a lot of that's alright. Ought to be good enough. Yeah, I could make a different hash table at some point. Maybe. And then we can also define what's known as an object pool, so we can get those IDs. What's going on here? And an asset, right? Is that the way it goes? No asset ID. Oh, interesting. Crying out loud. There we go. Right. So core hash table. The key is an asset path. and asset ID. So this is the path to ID map, right? Or maybe we call it a map. And then we'll have a object pool, which, how does that work again? Yeah. Asset. Then this is simply the asset pool. Have I pluralized that in the past? Let's go to the GPU system and see what parse Henry did. Right, plural is assets pool. Yeah, so we need to instantiate those at some point. So that's something I did forget, is the asset system initialization. We're going to need a way to asset system. So for now in the spec, all I want to do is pass in the number of assets, the capacity of the number of assets. I think that's all I need. Yeah, in the future there might be some other things, like how much memory we want. I don't know. Asset system init. Asset speak. I don't know, what's this section up here? It's like just it's like a maybe it doesn't need a section. Okay, so oh, wrong way. Right, so this is the asset stuff. And then this is asset system-y stuff. Always. I'm working on right now on a simple ass level editor for Vampire Survivors project. Nice, very cool. Game is not going to be that polished. We only have half a semester. In the next half of the semester, we have another project. This one is going to be 3D. Wow, interesting. You doing that in a custom engine or something else? Are you using like Raylib or something, was it, to help you get off the ground? Yes, typically you just do the initialization stuff last. Let's just get it all asset get. So here you pass in the I guess the asset ID. So this uses the object pull function. The reason why I make a nice little function for it is because I cannot be asked every time I want to do it to keep typing out this code. Object pull get. Oh yeah, generate it, right? So it'll be asset. There we go. Then the address of G asset system. asset ID in it. Right. So I'll return the asset like that, yeah? Does that return? You see, I think this asserts, which is probably quite problematic. It should maybe return null sometimes. But yeah, yeah. Where do we check if it's free? I guess the generation count is enough, isn't it? Yeah, maybe. What was it? Yeah, okay. Right, maybe that's enough. We can give it a, I don't know. See how problematic it becomes in the future. You can always change it. Yeah, so asset pool. Right. So yeah, this just ends up being able to be typed out a lot quicker and easier. Whenever we want to get an asset. So the thing is though, do I need to change it now? I think I need to. We need to know if it exists. And if it doesn't exist, oh yeah, that's the asset. Right, that one we get from path to an ID. Perfect. So yeah, we'll have to use the hash table API for that. Hash table finder insert. That one. All right. Okay, so the address of G asset system. Right, the key goes in there. So it's by a value, which bloody sucks. It does take the address of it though inside the inline function, so maybe that'll be all right. We'll see. And then is new. All right. So with this, we can say if is new. I should have returned the value, right? The value is the asset ID. If is new, we need to allocate in the object pool new asset and then set the asset ID. Core object pool, allocate. G asset system. All right, okay, so the way around. Cool. So that'd be an asset. Set the path. Ref counter equals 0. Now it's probably it's zeroed memory by default. Every time you allocate an object in the object pool, it's zeroed. It's guaranteed. So we don't have to do that. If it's... Oh no, but we will have to set it to 1. Right. Or maybe we can do this. Asset get deref of asset ID. All right, it's looking good. Cool. So you increment the ref counter. Oh, music went. Yep. Cool. I tried to make my 2D engine a bit similar to Relip. Nice. We're going to have pools in our engine mostly because there's going to be lots of enemies killed at once. I mean, I've told on Twitter with Jacob on how to implement a pool correctly. He basically recommended what you said some time ago on Discord, mainly just add a generation counter. Yeah. Awesome. Yeah, here's the guy with the cat profile pic and making that the shooter isn't it, the boomer shooter. Awesome. Yeah, object pools are like the bread and butter for me. Like I use them everywhere I can, and obviously it makes sense I use them. When I need when I have a bunch of things that I'm going to be making, I always put in an object pool. It's like a Super 7 array. It's pretty decent. I always pass around IDs instead of pointers. Quite nice. I hate those damn errors. They're hints. Say something else. Right. So then at the end we do return the deref of asset ID. Alright. Anything else we need to do here? So we now need to signal that it needs to be kind of loaded into memory in the background, in a background thread. But we don't really have background threads at the moment, right? So there's no point really doing it. But yeah, we might do it in the future, right? Yeah, for now we'll do the loading here. Yeah. So I think in the asset as well, we're going to want to have the memory. So I think what I'm going to do is probably just using virtual memory, just allocate it or something like that. Or maybe it's mmap it. Have I got, can I map a file? Map whole file or something? I don't know if I got that in. So a close is going to do this sort of, do a find. Oh no. It's generally just going to do an asset get. Right. And then we'll basically do a sort of like remove it from the, oh wait. Yeah. Asset ref counter minus equal 1. If asset ref counter equals 0, we do a core hash table remove G asset from the map. Asset path. Nice. So remove it from there. And then we do a dealloc in the object pool to remove the ID. So the ID will be invalidated now. There we go. So invalidate the ID and voila. Cool. Yeah, that's all right. So when it comes to getting the memory, let's check the operating system abstraction. What to do for virtual memory? Yeah, so I've just got a bunch of functions for virtual memory, but no actually reading or virtual memory mapping a file in. Cool. But we do a file read all. So what I might do is just memory map the just do something really dumb for now. Maybe just how do I get a file size though? Oh, does this just do, this is already kind of dumb, I think. What it does is use malloc. Yeah, I haven't changed that yet. Right, so we're already doing something kind of dumb, we'll just keep doing it. Yeah, in future we're going to change this API, obviously. It's using the buffered API, it's kind of crap. We can use the unbuffered API. I've got code elsewhere. I was just not bothered bringing it to this project. So for now, this will be good enough. Right, so I need to rightio. So the path is going to be, so we're going to actually make a path. So it's going to be, or maybe I do, path max isn't always defined. So we're going to send printf into that. Then the format's going to be asset. Where's the current working directory again? Right, so we run it. Oh yeah, I run it from the root directory, isn't it? Yeah, so we can just use asset and then paste on the end whatever's in path. So definitely got to do a get on the asset. To do move this loading, this reading code to another thread. Right, TSX just got a phone call. Hey, welcome back. Um, yeah, it's just my mother-in-law. She lost her glasses. I thought she put them in the baby's bag. She looks after him during the day. So let's have a look there. But yeah, do you need bidirectional lookup? Yeah, I've already got that, which is great. I had a bit of an idea. Yeah, thought that one through a bit earlier, I think. See if we can turn an asset ID and turn it into a path. Be pretty cool. So in the asset, there's a path, and we just get the raw string out. Boom. Chuck it in there. So this can... So I guess we've got to have a bit of a thing where it's like, in the open, we need to be able to check if the path... if the file actually exists. Right, that's another thing as well. To do check if file exists. We'll do that one in just a little bit. Let's just finish this off. So you pass in the path and you get back your things. So they're going to asset, memory, asset size. Yeah. Chuck them in there. Gives it a good old read. Returns a Boolean. So you can fail to read it if it doesn't exist, but did I do that log system in the end? I think I did it on Windows, then I... I got the log system. Maybe I could log. Kind of an error, isn't it? I gotta make a new tag. Rightio. Guess that'll be alright. So just simple logging systems, logs out. So we should be able to say Boolean right, so I want to say like failed to load asset. Nice. So that'll load it all in. And then we should just be able to literally return. Okay, that can return false. Then this can return true. And you set pointer out to whatever asset memory is. And then boom. Then this one needs to be able to do a lookup for the asset and give you back the path. Okay. Okay, so right, so we have an API for this at the moment. I've done it in the past though. So you can check if a file exists quite easy on Linux with the access. Or I guess we can do it. So let's go and add that to the abstraction layer. So we're going to be saying OS file so you need to probably be able to check that it is, like here you're saying it's an actual file. That's what I'm asking for, right? Whereas if you want it to be a directory or a file, you'd probably say OS path exists, right? So it's a very specific one, this. So I think it's implemented directly on Linux. Yeah. So I think we're better off using stat here because stat tells you it's actually a file, right? So I think it's like strut stat. Then you call stat on then in the stat structure there's a st I forget. St mode or link. I don't know, I gotta man this thing. I forget how. Oh, I forget you access the man page. Are you doing brackets? I forget. Anyway, we're here. So the mode field is regular file. Cool. So it's regular file. That ought to be good enough, I think. I think so. Well, no, this one can return an error code. So on error -1 is returned. Right, so if the path doesn't exist, then there's not a file. Therefore, it doesn't exist. Right, so then on Windows, we've got to do it as well, because we do run on Windows. I don't know the Win API so much. Win32. I think there's one called file exists, actually. Yeah. I've done this in the past, but I just don't remember it as well. So it depends whether a file system object, file or folder, right? Because it's like a path. I suppose one called file exists. Check if file exists. Get file attributes. Yeah, you use the A version as well. Good old D word. Right, so after you've done that, and then it's not a directory. I might break this into some separate things because here's the thing, when you're in the debugger, it's just nice to be able to see where it steps to. So you can do this. It adds more lines, but sometimes it's more desirable. Yeah, not directory. That should be the Windows one. Obviously, we don't have Windows installed on here, so it's not going to show up with correct checks or anything, but that should be it. All the file attributes are there. Okay. Bunch of stuff I don't really care about. All good. So now with this thing implemented, we can take it for a spin. So we'll do the log again, right? Because it'd be good if the system keeps running. It doesn't just crash because we're going to be building editors. It would be good if it doesn't crash. Failed to open asset. Cannot open asset as it does not exist. Awesome. Right, I think we've basically finished all the implementation. We've got to just do the initialization by the looks of it. But I think this is what we want. So then we can go around and find some places where we do read in files and replace it with the asset system. And yeah, we can move on from there. So we need to instantiate a couple of things. Oh wait, we need to be able to free some memory, isn't it? To do free. When we move away from that silly malloc. NOS file read all, right? So we'll do free asset memory. That's one of the first things you do. Can't believe he's a malloc. It's probably already included. Right, so here we're going to be doing like a core object pool init. G asset system. Asset pool the allocator. We've got an allocator in this would be the static allocator. It was in the game TLS. Yeah, I gotta figure out my allocation strategy for things. But right now it's got one static allocator where we just basically bump allocate memory onto it. And when we run out, we just need to up the number. So this is all the initialization stuff gets put on the static allocator. Then there's a per frame allocator where it gets reset per frame. And you just bump allocate it over the duration of the frame. It's doing alright for now. Yeah, this is inside the sort of game thing when we're inside the engine. It's a little weird. But yeah. Yeah. Alright. Man 2 stat. Right, I forget that. I remember it's been. Reminds me. Right, and then. Yeah, but I guess that's not POSIX maybe? Because they could maybe define it however they like. I don't know. Because the man page suggests doing it another way, using the macro. Yeah. I don't know if the macro is the way you should do it. Yeah, I'm not sure. Oh, that's a bit crazy. Yeah, I'll just use the macro. Macro easier. Okay, so I think I need to make my own key format function for the hash table. Hash table. Why have I got a rehash? Don't even need a rehash. Mine doesn't even grow. Oh, it's to eliminate the tombstones. Right, I see. Past Henry leaving notes. What a man. Right, initialization. Right, hash table allocated capacity, hash function. Oh. Right. Okay, so capacity. Does that have to be like... did I not do a prime in the end? What did I do? I did power of... Right, you put anything in and it rounds up to a power of 2. Right. Yeah, because primes are technically better, isn't it? Yeah, it's the power of 2 for this one. So it doesn't matter, I can just pass it in. Good. Now I need a hash function, so I think I just use the FMV hash 64. In you go, damn it. Now I need to pass in a key compare function. So I'm going to .h, there is a key compare and key hash for a C string. And that's all I need, because it is technically a C string. But it's just wrapped inside of a strut. So that'll do it. So it's a core key hash C string, core key compare C string. Helix. There we go. That should be it. So let's take this thing for a spin and yeah, see how it goes. So let's go into the main C file where all the fun happens. You know, maybe we should have an engine.c and an engine.h or whatever, I don't know. But anyway, asset, here we go. Maybe that'll do. So, when we boot up the, this is all engine-y stuff. Straight after the OS, we're going to boot up the asset system. Asset specification. Oh yeah, this is C. It's not C++, so I can do this. Ah, lovely. Right, so the asset cap is, you know, let's do 1,000 assets. When we get to more than 1,000, we can celebrate. It's a good celebration number. So let's instantiate the asset system and see what happens. Hopefully the computer doesn't blow up. Oh, that was the encoder stuff. Not that one. Scripts, build, sync, and run the game. Seems to boot up okay, so we've allocated some memory. The next thing we need to do is find an asset that we've got in the asset folder. That we actually load. So here they all are. We've got our test. You know, we've got the horrible font that we use. Wait, we don't use this anymore. So good old grep. Get out of here with that one. Oh, it's in the old graphics. All right. Okay, so we're definitely using the Liberation Mono though. We upgraded the font, right? Because it was looking painfully bad. And I actually made a piece of UI, which was the... I made a screenshot system. Bear in mind I got... Yeah. So I made a screenshot system with F12 and you can press Shift F12 or something like that. Or F12, I think. And it takes screenshots and you can compare two screenshots. And they move in sync with each other so you can get, you know, flip between them and compare. Then you can also... It's just a an image viewer, that's all it is, right? And you can also view textures that are in GPU memory. Stuff like that, right? So obviously this text was looking horrible because it was fixed bitmap stuff, but then we just made it better. So yeah, we definitely used some fonts there, so let's find those. All right, in the UI system, let's get in there and take it. So in the UI system, good old UI system. Here's the asset paths. So no longer do we do assets, right? It's relative from the asset directory. So maybe we should move them to a fonts folder. Because they're in kind of a bit of a dumb place, to be honest. Just being dumped in there. Like that. So let's make a directory. We don't need that one anymore. I guess the logo can stay there. That'd be pretty sweet. So, well, we do this. Silly git. Can't automatically do it by itself, eh? So, right, this is on the asset system we can do. So, well, Yeah, technically with the asset system, you want it to load on a background thread, isn't it? Yeah, so I guess sometimes you want to be able to. We're not doing that yet, are we? But yeah, I wonder if on initialization sometimes you want to load in all of your awesome assets, right? So maybe we change the asset. Maybe sometimes you want it to load in background. Hey Raf, thank you so much. Appreciate the happy affiliate anniversary. I don't know how long I've been an affiliate for. Maybe it's 2 years now. But yeah, and I don't know how long it will take me to get to partner, but you know that would mean twice the amount of people have to watch, and then that would also mean there'll probably be too many people to hang around and chat for me to keep up with everybody, which would be sad. I hope you're doing good. So I think we want to call it like a load mode. Um, so sometimes you want to say you want to background load it when you open it, right? And then you like maybe we just have different. You know what? Here's what we're gonna do. Well, that'll be private, so internal. No, it doesn't need none. Because I was thinking we have one where it's like background, load in background, load right away as soon as you open it, basically. Because for initialization, well, even for initialization, right? Maybe what you do is you say, maybe you would say, you go over all the systems that want to open assets at initialization, and you'll say, right, they'll open up all their assets. Those will go on the background thread. Those will get loaded in. And then when you get to the point of actually initializing them, you could then probably wait for them to be loaded in. And then actually do the initialization where they were required or something like this. Yeah, so maybe it is okay. The API we've got. Yeah, let's just roll with it. So the way it's going to work is we're going to say asset yeah, we didn't even like make a thing to shorthand this, did we? Ah. So maybe you take a literal and just cast into a pointer of it. The problem is you got to be of maximum capacity though, but you could. It would be safe. And then if you want to build it, you can always smprintf into it locally. Yeah, that makes sense. That'd be cool. My one concern though is the fact that that's a duplicate name to what this already is. So maybe you call it the path get instead of just path. Something like this, or maybe when you... These can't be an array of asset paths because what will happen is that won't be constant, right? There you go, thank you. Okay, we'll make access path. Yeah. I've already got that sort of make thing in my... Yeah, I could probably call it asset path make, maybe. Yeah. Potentially. Or initialize, something like that. Yeah, maybe that's better. Thing is, I don't know about this pointer though. Maybe it's a bad idea. Different type. Oh, that's in the is that in some header file somewhere? Right, let's change the name quick and that might help it. Right, that works. You can do the casting. Can you do the casting? We'll see if we do the casting. I think it's an internal. No, is it part? Where else did I declare this? Font paths. What's going on here? Yeah, it's just internal. I don't know what's going on there. Let's delete this. Meta font. Yeah, so let's bring those back and get jamming on that one. Yeah, I'm keeping it the way it is because it's shorter this way. Be using it a fair bit, I think. Cool. So we should be able to just open it like that. Huh. Oh, I left my drink downstairs. What a shame. What? Oh yeah, you got to do like a bit of a dot on there, innit? There we go. Because yeah, it'll be 0 if it isn't a null ID. Been returned, and it's going to assert. Okay. So now we're actually going to bring it to memory. So I guess we'll do another assert. This would be like an asset memory, passing the asset ID, and then we take the address to data, address to size, jobs are good one. Read font from disk, done. Cool. Yep. Now the final one is actually then just to say asset close. Like that. So let's give that a go, take it for a spin, see what happens. It should load in 4 fonts. Right, it didn't quite work out the way we expected. Failed to load font from disk. Right, it's a bit strange. So I failed to open it. Oh yeah. So what we need to do is we actually need to get a raw path. So I think we'll make another function which basically says it's about to write some C++ there. Right. Path, like a raw path or something, or a so that would be asset path plus 32, right? And then what we can do is I'm not sure if you guys know, but there's this bit of C API that we could probably use here. Hey video, got level editor working, was fun watching. Also programming, goodbye. Right. Good to see you, man. Have a good Wednesday. I'll probably see you Thursday. Catch you later. So here what we're gonna do is output the asset file path for a given asset path. Right. So there will be a destination. So there's a nice little bit of C API. Where I think you can do static. I think that's the API. Excellent. So this basically says that destination has to at least be this size. So if it isn't that size, it will complain. So what you can do is you can then do that sn printf thing. Drop that in there. And dst, I think that Right, so, oh, this is a great error. Size of will return the size of a chart pointer instead of a static to AE, right? Pretty nice. So that's fine because I already have this, right? And then it's just gonna right. So if you take a look at we'll take a look how this comes into effect. You'll see it in a sec. So if I were to replace this here, yeah. So the path is the address of asset path, and then destination is path, right? Maybe I call it file path, right? But you see there's no compile error at the moment. Now watch this when I drop this down by 1. Array argument 2 is too small, contains 278 elements. Coolie requires at least 288. So this means that you can pass in pointers to C arrays and have at least the size that you want. And that can be specified as a function argument. I only learned this like last week. I think it came in C99. I forgot. It's really, really nice. So yeah, it's only in C as well. It's not C++. Yeah, so we'll call that file path. Right, and we'll actually use the proper constant. This asset file path cap. Sweet. So now with this, we can actually do that again, but here. So we'll break this into its own little scope, and we'll be like A. So now we're checking the actual file path rather than the relative path from the assets directory. So obviously in future when we have a release mode, we'll have to check some other place for these to make sure the path actually exists, right? Some other way. Right, let's give it a run. Still failing. Still on the open. Alright, let's put a breakpoint here and see what's going on. Oh. That was in my encoder code generation thing. Okay, so file path. Right. Assets, fonts, liberation mono regular, TTF. That's about right, isn't it? What's error now? Error no 2. That's like no entity, isn't it? No such file directory, you bugger. Right. But it exists. Oh, asset. Go to that breakpoint. And boom. Right. That clearly failed, though. Text is gone. The text does not exist. That is weird. Right, so I don't think I think the problem is because we actually free the memory. We shouldn't actually close the font because I think SCV TrueType actually wants it to remain open. And I think that's where the problem is. There we go, fixed. So the texture viewer still has, we can still read stuff. Alrighty, that's good. There's our first assets loading through the asset system. We're going to hunt down any more assets that we're loading in the asset folder and to use the asset system. There's some environment maps. We'll do that one as well. I'm not sure we're using the logo. But yeah, we'll move over these environment maps and then we're going to look into the to-do list and maybe plan out the next. I have a tower of Coke cans next to me. That was the noise. Anyway, I'm just going to get my drink from downstairs and then we'll plan out some more things for the next few streams. There's too many Coke cans left for me. I will not show you these Coke cans. There's way too many. Right. Enjoy the tunes. POP. Pepsi. Alright, welcome back everyone. Yeah, I went upstairs and my wife had heard the Coke cans fall over. My tower of Coke cans. Honestly, it's better in room on my desk now. Anyway, got my H2O. Yeah, so we got these cube maps that we use for the environment. So in the graphics system is where that goes on. Let's look for file read. No. Oh. Is it straight with STBI? STB image. Right, so we need to do a from memory on that one, yeah? Alright, so let's go ahead and get the right, back to where we were. Let's get these two boys and girls. Drop them in there. So there's a path. So it's now just environment maps or whatever. And it gets to be a const asset path pointer. Fourth. None of this string copy crap. Path equal asset path. Oh wait, it has to be that. Damn it. Right. So that would then mean see, do I like it being called string in there? What are you talking about? Oh, I've not included asset. Let's get back into asset actually. I'm kinda liking, right? String, don't wanna call it string? We'll call it string. Typically I just call that sort of stuff data. That's called a string. Right, the size of path ought to be good enough. Right, so those two things can go like that. Yeah, I don't see any problem with that, to be honest. Then we get in there and chuck in the path, the address, get back an asset ID, and then we get a pointer. Void star image data. Image data, image size. Cool. Yeah, so just go ahead and now use the from memory variant. Pass in the buffer, which is image data, image size, and off you go. Loads it in there. Wait. Hang on a minute. This would be, let's call it data and size. Because obviously it's decoding a PNG file, right? There we go. So decode. So read in the PNG file, decode the PNG file into a raw set of pixels, and then upload it to the texture. So it throws into the staging buffer, and then it will get uploaded when we submit the command buffer. Yeah, so we'll just call the asset close and close that thing there like that. Done. So the thing is, right, it's basically triple buffering, is that right? So it's going to go from the file to the, I'm not even using the unbuffered API, so it's going through the buffered C API. There's one indirection. Then it's going into some temporary allocated thing. So there's two indirections. And then it's going into the command buffer. Sorry, it's going to the staging buffer. So there's three indirections. And then it goes into the texture on GPU. So there's 4 copies of the texture to get it into the GPU. So it does kind of suck. So maybe there could be a way for us to say, just load it directly. Just do the mem copy directly into the staging buffer, and that will at least do. Yeah. Anyway, let's put it to do there because it's very useful to keep track of. There is 4 copies before it makes it to the GPU. Sad face. First copy, C F read API. Right, they probably buffer it there. It is buffered. So there's one thing to remove. Second one is the temporary memory location. So it's the asset memory allocation. Third one is the staging buffer. Fourth one is the texture. Abstraction. Good old abstraction. So yeah, we've clearly got a lot of abstraction going on in here. You have to do these two, but maybe we could get it to go directly into the staging buffer at some point. Yeah, maybe. Right, so let's see if this works. Give it a run. If we have a background, then it works. Or if we have a cube map, there we go. So using the night background here. And then we have the not that one, the BRTF. The environment. Yeah, the pre-filter texture, which is the specular map. You have different MIP levels of that. And why is that moving like that? Shouldn't move. But yeah, so different layers as well. So this is the cube map layers. Yeah. It's all working. We're getting the full PBR thing as normal. Look. See the reflections in there. It's cool. Ignore its flickering, this is other problems. Right, so I believe that's the asset system done. There's no more assets really. I got this logo, but I don't know if I'm using that anymore. Maybe we can remove the asset. We are loading it. Maybe we'll switch that one over. I guess we can do it this way. I don't know. Let's just move it over. Oh, did I not copy that one? Alright, so the path is here. Asset path. Asset path. Yeah, this might be useful, and I might want to use it in the future. Let's just keep it loaded, I think. Not too bad. I don't delete that line. Cool. From memory. So it should be yeah, data size done. Right, so to give that a run, we'll check in the texture viewer and see. Oh. Oh, it's loading the screenshots. Shoot. Right. I clearly saw the next STB image I, and then I just glossed over everything else that happened. Right, these are screenshots, they're different. That's a different system. We'll let it continue to work this way. So basically we take screenshots with F12 and we save them in the screenshots directory. Yeah, these are not put into the Git repo, but it's just so I can sort of like, whenever I want to post something on a social media or whatever, or take two screenshots and do comparisons, or make a graphics change, I can compare the two images. They actually get loaded back into the texture viewer as well. And if I want to load another one back in, I just name it texture 0 or texture 1, and I can compare between those two in the program. So this is me just basically reloading it back in. Yeah. So where's that logo? Oh, it's in the old graphics. Okay. Cool, so we're done then. Run out loud. Okay, so let's just check that one in. Git status, git add assets, add source engine asset star, git add dot. So everything else that's not already been added, or that's already been added in the past. That should be. Oh, I didn't add dot, didn't I? You bugger. Checking on stage stuff again. I don't half the stuff. I think you can just do on stage nowadays. Right, restore stage as the thing said. Ah, silly me. What are we doing? So, logic, test, encode database, logic, test, generated star, and then test.cson. This is stuff I'm playing about with in the with the encoder system. Alright, that seems alright. So this is the asset git commit. Asset system. Yeah. Nothing more than that. So I guess let's tag the day and then we'll talk about the future. Yeah, so I'll upload that on the to the repo for those who have access to the code. So yeah, thanks to everyone who's supporting me. If you'd like to get access to the code and support the stream, you can follow that link there and yeah. So I want to talk about the plan from now on. And what we'll do next. So let's tick off the asset system from this to-do list. You know, for once, right, we got the estimate right. The estimate was one stream, we did it in one stream. That's good. Because we basically kept to what we wanted to do. The entity one I did overrun by about 3 streams, I think it was. And then I did a devlog for it. Encoder system definitely overran, but this one was... I was thinking maybe we... do something that's not too involved because we won't have a lot of types. And then I decided to change my mind and did something very involved. But we got something really cool coming out of the oven for that. So what we want to do next, so we're kind of building up towards making a material editor. It's not going to be anything complicated, right? You just can name a material. You can view an ellipsoid and just spin it around. And change metalness, roughness globally over that ellipsoid. And change the albedo. I think that's about it. I think that's all we got. We don't really have that many physically based properties yet. We just got the basics. So we kind of we definitely need the gizmo though for the model editor and the level editor, right? Those are pretty easy to do. We could probably get that done in another stream, but I did allocate 3 streams for it. So we might do this, the gizmos next. And there's also another stream for doing this sort of like render a mouse over feedback. So what we could do right now, since we've got like half an hour to kill, is let's just try and jam this out in 30 minutes. We want to just basically know what ellipsoid is selected, or should we do the gizmo now? Or we can research gizmos and have a bit of a think what we want. Yeah, let's do some research on gizmos. Not this guy. Gizmo. I remember that when I was a kid, man. Oh my days. Yeah, so we probably want something like this, right? Man, that was kind of freaky. Yeah, so we actually need a way to render a ring or a a donut, whatever you want to call it, right? And we can, like, I've already got vectors. I haven't got planes. Um, but yeah, these would be interesting. So why don't we look at the debug rendering and take a look at what we have available. So if you go to graphics, yeah, scale's a bit of an interesting one. Should look at those gizmos. Maybe let's look at some other gizmos for that one. But there's like a draw 3D. Right, here it is. So we've got an AAB, we've got an OABB. That could be a plane. Right. These you quite easy to plane with an OABB, right? So I think we've already got the drawing shape for that. We've got vector. So the OBB can go, you just got to get it into view space. So it could be in any, you take it from local space into view space, basically. Now, vectors, we can do them in view space or world space. So yeah, we'll probably be using the view space one and manually transform it into that. But we need a way to do like a ring. We've got ellipsoid, obviously, because we render ellipsoids all the time. And that one can allow us to put a border around it. But that won't be any op. So let's go to the IQ's ray intersection blog. You know, IQ's got tons of good bells and whistles, right? Let's find the so there is a disk. We could just use disk and then say do a bit of extra code to say, well, how far are you away from the edge? I'm sure there's information for that in here. Just got to figure it out. There's also, but the problem is with a disk. Yeah, what you really want is probably a torus. The torus is a bit complicated. It's a lot to translate, but it's possible. The disk is really easy though. Disk will be cheap. It won't look that good though. This is obviously made with mesh, as you can see the jaggedness about them. Whereas we'll just be ray tracing them. Yeah, just. So what we can do is probably do a disk. I wonder if you could let's have a bit of a play with it. Can you maybe make it a bit thicker? Oh boy, this is beautiful. Yeah. You know, C means center, N means normal, and R means radius. Just call it radius. Anyway. So ray origin takes center of, yeah, so you put it into the local space of, so you're basically drawing a vector towards the ray origin from the center of the disk. See, isn't this like just a plane, but with a bit of a radius? So it's like a squared length. plus redirection times t. So yeah, there's your right where you hit the plane. So I think if we reduced it down to a single, yeah, I don't think you can make it any thicker. That's for sure. You could definitely get rid of the middle. It's quite easy to do that. Um, yeah, where's the, I just wanted a simple, there's a num. Oh boy. Alright, so there's two of them. So if you get rid of the, yeah, if you make the, so you make that like a really big number, like infinity, basically. You do see, yeah, it's basically like a plane thing, and then it checks the radius, right? So yeah, the way you'd get rid of, say we say if length squared greater than min r, let's say 3. Right, so we're saying if that is greater than min r squared and oh, maybe it's a bit too big. There we go. So we've got a bit of a hole coming in, but maybe it is not as we expected. Increase the number of disks. Okay, so I'll get a hole in the middle now. I guess it looks a bit off because of the perspective. But yeah, so we can easily get the hole, right? It's not too difficult to do that. There you go. So you can get these sort of like ring things just using the disk. My concern is though that they go two-dimensional, and then the torus would just be better. But it's a lot more code. Mm. And because it's a plane, it does it testing against a plane, doesn't it? Well, you could test against two planes. What could you do, eh? Well, if you did two planes, you could get two sides. You could get two rings going around, space them a bit differently. Um, Right, maybe, just maybe. Uh, it's promised when they go flat, right? But you would always get if you did two rings, you're gonna get the same problem because they're gonna be. And if we look at like a gizmo or something, yeah, it would be nice to have it a bit. Yeah, maybe okay, maybe we can't do this one, but at least we explored it. Um, yeah, because here's the plain one, right? It's basically the same as. Well, that's a bit different. So there's a random box. There's the Taurus. I wonder if there's a cheaper Taurus. One that's just less. I guess it's quite a bit in it. Obviously we can write that out, it's not bad. But the Taurus would be pretty neat. Because then we can make nice looking rings that we could then basically click and do the rotation stuff. Um, Wanted to use this in my conformal torus shader, however, some issues. Okay. Well, there's a more simplified one. Where's torus? I wonder if there's another one. Well, we could remove stuff like that. Damn it, shader toy. It takes so damn long. Yeah, it gets a bit much, doesn't it? Maybe there's another way. We just got to implement that reverse torus thing. Hmm. Okay. Cool. Well, yeah, we could just copy this, paste it in, and refactor it basically. So we add to the draw 3D. If we add the reverse torus, let's take a look at the vector. Right, so we can change. That's the. Hang on a minute. Okay, that seems to be the width, and this seems to be the thickness. Right. Yeah. Nice. Yeah, it's pretty good. So we can probably break those into two separate parameters. Give it like a radius. They're both technically radiuses, right? So yeah, one's like a radius for the actual ring, and the other one is yeah, like a thickness or whatever. Cool. Right. Any other things we should look at for next time? So yeah, we'll use the torus for these rotation ones. We're gonna have two planes, right? Also, I have three different planes you can drag and move around on. Um, for scale though, that's the bit of a weird one, right? Like a scale gizmo. People typically put blocks on the end instead of an arrow. We could always do that, right? Instead of where the cone is rendered, we put the box down instead. It's not too difficult. Yeah, some people like do ones that join everything in one big old gizmo. Right, it's possible to do that. I think what you want is a closest point on circle, the line in 3D, then you use the point to the line distance to check for radius. I'm not sure what you're saying exactly, but right, but you've just given me ideas. I've already done this code for the damn. The torus is a blown up circle by radius. Yeah, it's like a swept circle around, isn't it? Oh wait, it's a swept sphere. But yeah, no, I've done this trick before, but it won't be that good. It'll still be 2D. There's another trick you can do with a sphere. You can just use the normal and color it based on. Yeah, that won't work though. Closest point on a circle. Okay, a circle and then a line in 3D. Then use the point to line distance. Right. I think I see what you're saying. Maybe that is possible, and that could be quite cheap. It won't look, might not look that good in some cases though, maybe. Yeah, the other thing I was thinking, but it probably won't work, is norm, where you at? Right. So what you can do, let's say if uh yeah, no, it won't be that good. You can basically check the normal and just only show it if you hit directly along the X, Y, or Z with some epsilon. But you don't need, yeah, it won't look that good. But I see what you're saying. Let's get the drawing thing out. So what you're saying is like you have this sort of like disc essentially, or a circle in 3D. You have like a line which represents your ray. And you do a closest point along ray to a circle in 3D, then that'll be this one. Then you check your distance to the edge of it. Your distance to the edge. That could do it. That might be quite cheap as well. I don't know what you're linking to, Yuki. What is that? Hey Albert, thank you. Let's take a look. If shader toy would load. Being a silly right now, isn't it? Taking its time. Link is safe is a page that I'd like to show you. Yeah, but I don't know what it is. Is that your first time you're saying hi and then you're just saying like, look at this? Oh. Thick disk. Is this ray march though? Yeah, it's ray marching. I'm ray tracing. See, it's returning a distance. That ain't quite it. It's close though. But yeah, if we take that disk. Yeah, maybe we take that disk, you know? Or I could just copy, you know, I just need to get it done so the torus would just work. But if I was trying to hyper optimize it, maybe the disk be the way to do it. Like, oh, there's one with backface culling. Interesting. Obviously, it's just with a normal check in it. But yeah, we've already removed the center from it before. But this is not going to do it because the dot product in the ray direction are normal. And the normal and the ray. Yeah, it does it along a plane. It's not going to be. But yeah, you need to do the closest point on line with a circle. There's a ray circle intersection test. Maybe expand this to 3D. They call it a sphere, damn it. Yeah, maybe it's possible to take this code chuck it in this example and mess with it. So what you're returning -1. Then here you're returning no. Right, so RO the other way around, isn't it? The wrong way around. What are you talking about origin for? Light position. That's target. And that's origin of the screen? No, it's pixel. Oh, these are more crap variable names. Come on. Right, it's just pixel UV counted with aspect ratio. So target is the light. Okay, so you're right. So then those two we get you the ray direction. We'll get you RD, right? So that's RD. Right, we're getting somewhere. So origin was the where else is that used then in this? Origin takes sphere center. So you're trying to render a pixel. Right, it tells you whether to render the so ray origin C C C I don't think this is gonna work. Yeah, it's too much. Okay, so I think we'll just port the torus code over. We just need it to work. So we'll do that in next stream. So we'll port over the torus code and we'll probably, yeah, maybe we can do the 2D circle thing in the future if we need the more performant version. And we'll probably do something like these, right? Maybe we could do gizmos where we, sometimes they do like all-in-one gizmos where they'll sort of have all of them active at the same time. But I don't know. We can just do separate ones. And then we just have to do a bit of feedback. So when you've ray traced against it and you click on that ray traced one, it gives you the, lets you know you've clicked on it, on which one you clicked on. That shouldn't be too hard. Right, so that'll be on Thursday. We'll be doing the gizmos, testing those out. Yeah. So hopefully we can get that done in 1 or 2 streams. See how that goes. Okay, so let's find someone to read. Ah, it's very arty. It's been a while. Alright, see you later, Anzenris. Thank you for popping by. But yeah, have a good Wednesday. Hopefully see you all Thursday, if not Sunday. But yeah, I'll see you all soon. Bye bye.